let's solve this equation where we are looking at special cases. In the given equation, S and R are constants and S is greater than 0. If the equation has infinitely many solutions, what is the value of S? Okay, so we have infinite solutions. So what that's going to look like with an equation like this is that the constants are going to be the same on both sides of the equation and the coefficients, okay? Now, when they give you this information, S and R are constants, that just means it's some number, and you're just going to pick that number to make it work for what you need it to equal. So the first thing we have to do is kind of simplify this a little bit. So let's divide each of these by 4 so it will look a little nicer. And let's distribute the R on the other side. Okay, now we can see that our coefficient is 3. Our constant is a little bit confusing looking because it's actually this whole thing spread out. But we can kind of do a little matching game on each side to see what needs to match, because we need for infinite solutions the constants to match and the coefficients to match. And so we know, just comparing the 3x and the rx, we know that r is going to have to equal 3. And then if we go ahead and fill in the other part, let's go ahead and fill in the other side with r equals 3, because we know this is going to be a 3x minus 24. So this 3x just corresponds to the 3x over here. But now let me choose a different color, because this is all part of the constant. And now we know the constant is going to be negative 24. So we can just do 7 minus s over 13 equals negative 24. And you could solve this on Desmos, but we can also subtract 7 from both sides. So we'll get negative 31. And then you can multiply both sides by negative 13. And let's see what it gives us. And don't worry, you can also punch that into Desmos. But if you ever use Desmos to solve an equation, just remember that it's going to have to have a variable of x if you do that. So keep that in mind. All right, so S is 403, and that's what we were looking for. And we are done with that one.